Hello champions, welcome to Gagan Online Academy, Kadapa. In today's session, we are going to start a new chapter for senior inter students. That is complex number 2A maths. Complex numbers. Complex numbers are not difficult. Fear makes them difficult. This chapter is pure logic, pure scoring. If your basics are strong, marks are guaranteed. No logic, no shortcuts, only understanding. Let's begin. Complex numbers. If a number is in the form of a complex number is in the form of a plus ib. Okay, number is in the form of a plus ib. That is called complex number. This complex number is denoted by the letter Z, capital Z, A plus IB. Here, A is called real part of the complex number, real part. A is called real part and B is called imaginary part. B is called imaginary part. Symbolically, we write real part as a real part of complex number, that is A, and imaginary part im of z, that is equal to b. Square root of minus 1 is taken as I. Iota we call it iota. Iota is equal to square root of minus 1. So I is equal to square root of minus 1. Now we can find I square value, I cube value, I to the power of 4. Square root of minus 1 is taken as I. So I can be written as square root of minus 1. Now we square on both sides. So by squaring I, we get I square. Here square, this square root gets cancelled, minus 1. So I square is equal to minus 1. Again, we multiply on both sides. Both sides by I. So I into I square, this side minus 1 into I. I multiplied both sides by I. I into I square, I cube. That is equal to minus 1 into I, minus I, minus 1I. So I cube value is minus 1, minus I. Similarly, I power 4. I to the power of 4 can be written as I square into I square. So I square value we know minus 1. So I am writing here minus 1. Here also minus 1. Minus into minus plus 1 1 ja 1. So you should remember them. I value, I square value, I is square root of minus 1. I square is minus 1. I cube is minus I. I to the power of 4 is plus 1. I to the power of 4 is plus 1. Modulus of a complex number. Z is equal to A plus IB. This is a complex number. So we have to find out modulus of a complex number. So modulus of complex number is written as modulus of Z and square root of A square plus B square. Square root of A square plus B square is called modulus of a complex number. One example. Take 3 minus 4i, one complex number 3 minus 4i. Okay, to this we have to find modulus of modulus. So we write modulus of z, that is equal to square root of, first square this 3 square plus the coefficient of I, that is minus 4, square this. Now 3 3 is 9, 4 4 is 16, minus becomes plus. 9 plus 16, 25. Square root of 5 is, square root of 25 is 5. So modulus of this complex number is 5. Division of a complex number. This is most important for board exams. Find 2 plus 3i by 1 minus I. See, in numerator we have one complex number, in denominator we have another complex number. So now we have to perform division. I am writing here 2 plus 3i by 1 minus I. To divide one complex number by another complex number, we have to take conjugate of the denominator. Conjugate of 1 minus I is 1 plus I. So take conjugate of denominator and write it in numerator and denominator. So I am writing in numerator also same conjugate. After that we have to multiply. 2 plus 2 into 1, that is 2, plus 2 into I, 2 into I, 2I, plus 3I into 1, that is 3I, plus 3I into I, 3I into I. First write number, I into I square, 3I square, whole divided by, see, A minus B into A plus B. This is in the form of A minus B into A plus B. So A square minus B square. A square, that is 1 square, minus B square, that is I square. Next, 2 plus 2I plus 3I, that is 5I, plus 3I square. See, 3I square value is minus 1. So plus into minus minus, 3 1 is 3. So 3A square is minus 3. 3A square value minus 3. So I am writing here minus 3 by 1 square, that is 1, minus I square is minus 1. So 2 minus 3, that is minus 1, plus 5I by 1, minus into minus plus 1. So finally we got minus 1 plus 5I by 1 plus 1, 2. Now we are separating real part and imaginary part. So minus 1 by 2 plus 5 by 2I, 5 by 2I. So this is A, this is B and I, A plus BI form. So in this way you have to perform division in complex numbers. Find 2 plus I into 3 minus 4I. Now we have to perform multiplication. See, first write 2 into 3, that is 6, plus into minus minus, 2 into 4, that is 8. Now we multiply two complex numbers. One is 2 plus I and the other is 3 minus 4I. See, first take first number 2 into 3, 2 3 is 6, plus into minus minus, 2 into 4I, 2 4 is 8I. Next with I, plus into plus plus, I into 3, that is 3I. Number first, complex number next, plus into minus minus, I into 4I, I into 4I. So first number, here there is no number means 1, 4 1 is 4 right here, I into I square. Okay, then 6 minus, here minus 8I, 8 i's, 8 i's, here 3 i's. Okay, subtraction, 8 minus 3, 5I. 8 is bigger than 3, so minus symbol. Here minus 4 into I square is minus 1. So 6 minus 5I, minus into minus plus, 4 1 is 4. 6 plus 4, 10, minus 5. This is the product of these two complex numbers. Conjugate of a complex number. If Z is A plus IB, then its conjugate is represented by Z bar, that is equal to A. In the place of plus write minus IB. So A plus A minus IB is conjugate of A plus IB. Conjugate of A minus IB is A plus IB. Now some values we have to find, that is Z plus Z bar value. Okay, Z value is A plus IB plus Z bar is A minus IB. Plus IB minus IB gets cancelled. A plus A 2A. So remember this values, Z plus Z bar is 2A. Then Z minus Z bar. Z is A plus IB minus Z bar, right in bracket. Then if you open A plus IB minus into plus minus a, minus into minus plus ib. Now plus a minus a gets cancelled. ib 2bi 2bi. Okay, this result also important. Z minus z bar is 2bi. Finally, z into z bar. Z we know a plus ib into z bar a minus i. A into a square plus into minus minus a into ib, that is abi. Next plus ib into a abi plus into minus minus ib into ib, I square b square, I into I square b into b square. So this will be a square minus abi plus abi. Here minus I square value is minus 1, b square. Minus abi plus abi gets cancelled. A square minus into minus plus 1 into b square b square. So z into z bar is equal to a square plus b square. These results you have to remember while solving big questions. Find 1 plus 2i into 3 minus 4i. We have to multiply these two complex numbers. So here 1 into 3, that is 3, plus into minus minus 1 into 4, 4, this I, 4i. Next with 2i into 3, plus into plus plus, 2 3 is 6, that I, plus into minus minus, 2 into 4, 2 4 is 8, I into I square. Next 3, 6i minus 4i, that is plus 2i minus 8 into I square value minus 1. 3 plus 2i minus into minus plus 8 1 is 8, 3 plus 8 11, 11 plus 2i. So in this way we have to perform multiplication. Argument of a complex number z is equal to a plus ib. This is complex number, right? Complex numbers are represented by the letter z. Now for this, tan theta is equal to b by a. This coefficient of I, b, and this a. If we divide b by a, we get argument of a complex number. Tan theta is equal to b by a is called argument of the complex number. Complex numbers can be written in polar form. We know complex numbers a plus ib. Complex number is in the form of a plus ib. So for this complex number, we have another form, that is polar form. We can express this complex form as r into cos theta plus I sin theta. Okay, z is equal to r into cos theta plus I sin theta. This is polar form of a complex number. Here r is modulus of z. R is modulus of z. Modulus of complex number. Z means complex number. I told you formula, that is square root of a square plus b square. A square plus b square. Then theta. Theta is argument. Theta is called argument. Simply we write arg of z, argument of z. I told you tan theta is equal to b by a. From this theta is equal to tan becomes tan inverse b by a. This theta is argument. Argument means theta value. Okay. Equality of complex numbers. If a plus ib is equal to c plus id, A plus IB one complex number and C plus ID is another complex number. If these two complex numbers are equal, in that case, this real part A is equal to this real part C. That means A is equal to C and B is equal to B. If 2x plus 3 into I into 4y minus 1, that is equal to 7 plus I5, then find x comma y value. So here we have equal symbol. That means this question is on equality of complex numbers. So real part should be equal with real part and imaginary part should be equal with imaginary part. So I am writing this equation 2x plus 3 plus I into 4y minus 1, that is equal to 7 plus I5. See here in 2x plus 3 there are no i's. So this is equal to this real part 7. That means 2x plus 3 is equal to 7. From this 2x is equal to 7 minus 3, that is 4. X is equal to 4 by 2. Okay, 2. X is equal to 2. Now imaginary part, the coefficient of I is 4y minus 1. So 4y minus 1 is coefficient of I. So here coefficient of I is 5. So write 5. Now 4y is equal to, this minus 1 becomes plus 1. So 6. Y is equal to 6 by 4. Means 2 3s and 2 2s. X is equal to 2 and y is equal to 3 by 2. These are x comma y values.